have a discussion about oh, okay, sorry, just wanted to see what that said. We'll have a discussion about both the routing working group and the presentation given by Professor On. So feel free to ask questions as we go or save your questions for discussion. I'm hoping that this will be a collaborative forum, not just me speaking out to you all, but a collaboration and a place to discuss some of these things that you'll see. So what does the International Routing Working Group do? So we established this group to work on international routing issues to improve R&D data transfer performance and performance in general. The goal of the group is to engage network owners and NRENs from all around the world to not only react to issues that we're seeing, because a scientist comes to us and says, I'm seeing poor performance on X experiment, or I need this to work better for Y experiment. We want to become more proactive and proactively look at routing throughout the international GREN, the global R&D network, and create policies to prevent these routing issues from occurring, and also create a community where you feel comfortable and you have people you can trust to go to if you see an issue that you want guidance, suggestions, or help troubleshooting. So the co-chairs are myself, Brenna Mead, Warwick Mitchell from RNet, many of you know him, and then my colleague Hans Adelman, also from International Networks at Indiana University. Why did we create this group? R&E networks over the years have solved the problem of resiliency and redundancy, but what we haven't solved is efficient routing. We have so much resiliency, so much redundancy that traffic is getting where it needs to go, but it's not necessarily taking the most efficient route possible based on all of these different paths that we've created as the GREN system. And I've been a network engineer for almost 15 years, 12 years. And as many of you network engineers or people who have network engineers working for them know, network engineers are interested in operational status. Is my link up? Is it performing? Is it up or down? Or was it an outage? They're doing upgrades. They are not necessarily focused on performance. They are not necessarily focused on how traffic is getting to a destination and whether that's the most efficient route. They just want the traffic to get there, and they will react to a problem if it comes to them. And so the point of this group is to be more proactive. Many of you know that run research and education networks, research relies on performance, minimal latency, low RTT, maximum data transfer speeds. And so the goals of a network engineer versus a researcher are not aligned always. And that's what this group is trying to coordinate better and do as a group. Something we know as network engineers is routing doesn't necessarily take care of itself. BGP just works, yes. That is, we say that all the time as engineers. But when a new link comes up, BGP doesn't necessarily adjust to send traffic over that new link. Old routes may not work well with new links coming up or new networks or changes in network infrastructure that's happening within the GREN. And oftentimes, your traffic is not taking the path that you think it is. It's getting there, but it's just not taking the path that you as engineers think it would take. And we as engineers may not have time to be looking at that every day to make sure that that is working effectively. So there's a very big difference between research and education networks and commodity networks, as I sort of touched on. Research and education networks rely on bandwidth, performance engineering, a community of people working together to create research endeavors, and then deterministic behavior. Whereas commodity networks they're looking at traffic shaping, DDoS protections. They don't really care about the architecture. All they really care about is that your traffic goes over their network and gets to the next network to get to wherever this traffic needs to go. They are not performance engineered for good data transfer performance, for research, for these large data transfers that are coming from projects such as LHC, the telescopes, all of these large science projects that need decent research or decent networks in order to have effective data transfer performance. So R&E networks are engineered to support science. Commodity networks are not. And we as R&E network engineers, our focus should be keeping R&E traffic on science networks because it's better for the researcher, And we are traffic engineering these links to be most effective for these researchers so they can do what they need to do and not worry about whether their network works. And hopefully they're not putting things on hard drives, putting them on boats and sending them thousands of miles instead of using your network because it's too slow. So the routing working group has two primary goals. We have an engineering focus, which is to document erroneous routes and identify teams to address them. And then really what this is a community of people that you know and you can trust and that you've worked with, that you can go to with issues you see in the future, issues you think you may see with new links, or even just really any troubleshooting, educational or otherwise advice that this community of engineers can give you. And then we also have a policy focus. So we are interested in routing policies, backup paths, and then most importantly, which I don't know that we do very well as a community, is verify that these policies are actually being followed. Because we all get busy and we all have, you know, a number of projects going on all at the same time, and sometimes policy suffers in that case. So in order to do this work, I've been leading this group for about 2 years. I primarily use a tool called NetSage, which is a platform that many of you in this room, specifically those of you that contribute to APONet, contribute SNMP and sometimes flow data to. And then I take a look at that SNMP and that flow data, and I look at how your traffic is going through the APONet system and the GREN community using NetSage. NetSage is a very good tool to find information on data and volumes, so data rates and volumes. And it can also clue you in as to how the traffic is being routed as well. And I'll show you a few examples of that later. Some other tools as we use NetSage to identify some of these cases that I'll go into in a few minutes. Once we start digging in deeper, once we've identified the teams that can help us work on these cases, then we use trace routes, route views, peerings, looking glass, and then really just looking at BGP from the different engineers that are working within the group. So over the past 2 years, we've observed quite a few international routing challenges, one of them being asymmetrical routing. I want to be clear that asymmetrical routing isn't always bad. It doesn't necessarily have to be fixed. So part of what the routing working group does is determine why it's asymmetrical and if it's supposed to be that way. So asymmetrical, for those of you who may not know, just means that it takes one route from a source to a destination and a different route from that destination back. But part of what we do is identify asymmetric routing and go to NRENs and network owners and say, we're seeing this. Is there a reason for this? Is this what you want? Can we help you fix it? RNE data taking a less efficient route around the world, which will affect performance. Like I said earlier, latency is key in large data transfer. So if you're taking a much longer route around the world than you're supposed to, you're going to have more latency and you're going to have more trip time. So some examples of these that we see are Europe to Asia routes traversing the US. So you're going all the way around the world instead of point to point. Also Africa to Europe routes traversing the US. So another one is RNE data that takes a commodity route when an RNE path is available. So I touched on that a little bit earlier. As I said, science flows should stay on RNE networks. And we've seen it quite a few times as a community. When we see RNE traffic on commodity networks, does not have the performance that we see on RNE networks. That is why we have RNE networks and don't just let the commodity networks run the world, because we have a different set of goals that are different from what commodity networks are tuning for. And then the final one is new RNA links, RNA links that are removed or added, but BGP doesn't adjust appropriately, or architecture isn't adjusted appropriately, so the traffic doesn't actually move to that link. We saw that with our Singapore to Guam link that our team works on. We brought the Singapore to Guam link up it was working and there was no traffic on it because we never adjusted peerings, we never adjusted local preference, we never adjusted the system to put any traffic on it. Once we discovered that, obviously we just worked with the group and fixed that. So it's very important as engineers to not only bring the links up and look at up-down status, but also to make sure that, again, that your traffic is using the link you just brought up and the performance on that link is good. Through the routing working group, we have a case process. So cases are submitted via the mailing list, Slack, or at the monthly meeting. We meet the third Tuesday of every month, and we switch off between early in the morning US and late at night in the US to accommodate both Europe and Asia, and not really accommodate me. As you can see, those are terrible times for me, but it's okay because we want to have the most engagement in these groups as possible from the GREN. So this one now is actually in very late in the US, this meeting. So then the teams are selected within the routing working group. So we reach out to the routing working group and say, hey, we have a case that is involving, for example, KAUST and KISTI. And we say, are there any engineers in the routing working group that would like to work on this case? And then people respond, and then we start that case up, and it becomes a case within the routing working group. That case is then added to the master case list, which is how we keep track of how many we've solved, how many we still have open, and how many are on pause due to a variety of issues. Then we create a folder that only has access to those specific engineers that are working on that case so that we can keep all information private for those engineers that are actually working on that case. And then we give case updates at each routing working group meeting on the progress of those cases and whether or not they're closed, open, or what is hindering us from solving those cases. Currently, we have 170 members subscribed to the routing working group list. Quite a few of them are actually in this room. Thank you for coming. We have 21 total cases, 17 solved cases, and 1 case on hold due to lack of resources from that NREN to work on the problem with us. So in the past 2 years, we've had 21 cases, and we still have about 4 months left in this year. So I'm hoping to get to around 25, meaning 12 a year, 1 a month. I think those are pretty reasonable goals. This is just a graphic that I made to kind of show the diversity within the group and how many different organizations we have. We have a lot of organizations from the US, but we also have people from China, Indonesia, Germany, various parts in Europe. So it's a very diverse set of people within the group in the Slack channel, and it's allowed for a wide variety of collaboration, and the community is actually very diverse and very interested in collaborating together. It's also created some new connections within various NRENs. So through this group, we've been able to connect people who did not know each other previously to engineers at other NRENs that have created new collaborations and new resources for people to rely on within the community. So I'm going to go over some of our closed cases, so some of our highlights. I only have a few, and then I have some open cases that I'll go into that we've just started working on. So they are just being, the teams are just being identified. And if anyone in this room would like to work on those cases with me at the end of my presentation or through email over the next few months, feel free to reach out. So we'll talk about some closed cases. One of the most interesting cases we had last year was internal to Saudi Arabia traffic traversing the US. So 2 institutions within Saudi Arabia were doing data transfers between each other, and we saw their traffic over NEAR, which is in New York. So 2 institutions in the same country are going all the way around the world and back to collaborate with each other. At the time, when I reached out to KAUST, they said, well, this is the most efficient route because we have a 50 megabit connection between the 2 universities, and we do not have connectivity to the local NREN main. As a result of this case, I was able to work with KAUST and bring them more and more data, and they were able to go to their local NREN main and say, this is poor performance, this is affecting science. And they were actually able to establish a direct link with the Saudi NREN, and the internal to Saudi Arabia traffic is now no longer taking near. The other benefit of this, initially, the only peering to Internet 2 that KAUST had was over the near link that my team actually is responsible for. Now they have peerings through main with Internet 2, so there's additional resiliency. So now they can get to Internet 2 from either main or near, and if there is a cable cut or an outage, they have resiliency and redundancy now that they didn't have previously. Data transfer performance has also dramatically increased as a result of this, because they're not traveling halfway around the world to go less than 1,000 kilometers. So this was what we saw before April 2023. So this was so quite a bit of traffic, very slow rates. This was over near, and now we see nothing, except in any case where we have any outages with their peering, the direct peering with main. Another interesting one that we saw internal to Asia traffic traversing the US. So we saw Hong Kong to China traffic in the US, specifically large flows from Beijing to CUHK over to our network Transpac. These slides will go out, so if you're interested in actually looking at the NetStage dashboard that I use to see these things, I have all the links within this presentation. However, sometimes when I've tried to do live demos of NetStage, we've had some loading issues, and network reliability is an issue. So if you would like me to go into more about NetStage, I'd be happy to during our discussion section, but I also have links in this presentation for if you just want to take a look on your own. So we reached out to CSTNet and HARNet, and they were able to adjust their peering. So the traffic is no longer taking Transpac, and they also saw a dramatic improvement in performance and started to build. And we, as a routing working group, now have members from CSTNet and HARNet in the routing working group for future cases that we may see that are along these lines. This was an interesting one. As I mentioned earlier, we have a Slack channel. And so you can submit your cases at meetings, over the mailing list, or in the Slack channel. This case actually was started in the Slack channel and solved in Slack. So we saw traffic on routes between European NRENs, not just one, from many of them. So DFN, some GNA, SURF, could not get connectivity to Universidad Nacional de CIU, which is in Mendoza, Argentina. It was dropping traffic for multiple days. And so that case was put into Slack, and we all started working on it. And in that Slack channel, we had engineers from ESNet, DFN, Internet 2, and GNA all collaborating within Slack to start to troubleshoot what we saw. What we ended up discovering was a routing loop. As you can see there, I highlighted it in the red box. It's basically bouncing from those two IP addresses, and the traffic is just sitting in a loop. And that is what caused all the routes being dropped from those European NRENs to Argentina. So once we saw that, we worked with Red Clara, and the trace routes have been fixed since February 10th. We saw a dramatic improvement, and the routes were not being dropped anymore. This was our first case, actually, of a routing loop within the routing working group. So this wasn't necessarily an inefficient route or science traffic taking a commodity route, but it was something we were able to solve quickly in less than a day through the routing working group Slack, and through the culmination of all those engineers that are in that Slack channel just working together to take a look at those trace routes. So yes.
How did this come about? This loop, was there a misconfiguration on someone's part? Or?
Yes, it was a misconfiguration. They were doing what they thought were minor upgrades, and there was a misconfiguration. They said they'd hired some new engineers, and there was a misconfiguration, and that's what caused that loop. It was actually a good experience for the engineer that did it. I think as an engineer, many of us know you learn the most from breaking things and then fixing them. So the engineer that we ended up working with to fix this was the one that broke it. And he was able to fix it. And it turned out to be a good experience for him. Something that I think is really important within our community and within the routing working group is we have a lot of engineers that are young and new to the R&E community. And this is a community that you can't just come in and understand. There's more than just engineering. There's a lot of people to understand. There's a lot of collaborations to understand, and there's hundreds of countries that you're going to be working with and hundreds of different engineers. So I think as we start to train young engineers, it's important for us to have a group like the Routing Working Group or other groups that help these young engineers make mistakes, identify them, fix them, and support them as they grow in this NREN community. Because many of our engineers are retiring or becoming directors and other things, which is their path. But we also have new people coming into the community that need to learn and need to make mistakes and need to build this network that you all have. And we need a way as new engineers to build that network just as you all did. So one of my goals, which is not necessarily, it's more of a higher level goal, is to create a place where these young engineers or mid-career engineers can come and feel comfortable asking questions and making mistakes and learning. So this was a pretty interesting case of that.
Sorry for
Of course, no, questions are good.
I think it's good that we are not just fixing problem, but learning from it and also sharing that the process of tracking them down. It's also pretty important so that if things happen, we know what to look for, what to look at, to solve a problem. I know different problems need different eyes to look at it, and that's where the experience of some of the network engineers that are in this team around the world provides.
Absolutely.
So I think it's important to keep not just we solve this case, but also some of the thoughts on some of the things that you did to solve that case as well.
Yes, the collaboration. And I think, for me, part of what this group has given is occasionally I'll see strange traffic on our links, Transpac and Near. And now I have over at least 20 engineers from different NRENs that I know I can go to and say, hey, this doesn't look right. How is this? What are you seeing? How can we fix this? And it's developing a community for me and others that is a community of trust and resources that you can go to ask questions and solve some of these issues and help troubleshoot, really. So we have, I believe, 3 new cases that we're going to start working on over the next 4 months. So this is all done in NetSage to start. I will say that I find most of these cases, occasionally, like the Slack example, they come to me and we work through them. But a lot of the time, currently, it's me going out in NetSage and finding traffic that looks erroneous or doesn't look right or potentially needs to be explained. And then I come to the routing working group and present these cases. I'm hoping over time, as we grow the group and the collaboration and we get to know each other, that more cases will come from the community to the group, and not just me. But as we go along, but trust takes time, and as we continue to grow the group, I think that will happen. But collaboration and trust isn't a quick thing. It's something that grows over time. So an example that we just saw, traffic from Taiwan to Japan traversing the US via Seattle, Transpac, Pacwave, and LA. So going 2 different directions to the US and back to Japan via LA and so Sato-san and I will be working on this case very soon. See, there's your name. So we're going to reach out we have contacts through the routing working group. These 2 from Taiwan are in the routing working group, so we have reached out to them, and we're going to start working on this case together just to see if there's a reason for that. It could be intentional. It doesn't necessarily mean that it's bad, but we are seeing generally poor performance, and Taiwan and Japan are not very far away from each other to be going all the way to the US and then coming back. So we'll be working on that case over the next month or so. Another one, Alex, I know you love me. Traffic from Kaust to Kisti is traversing near, which is in the US also. So Saudi Arabia to South Korea. The other way, it is taking Singaran. So I know that there is the seemingly correct path would be Singaran over to South Korea. However, we're seeing traffic go over near Saudi Arabia to Korea, but not if it goes from South Korea back, it takes Singaran. So there's some asymmetrical routing happening here, and there's also some performance issues happening here. And so as you can see, so in that stage, you can see what sensors observe the flows. So there's the PACWave switch, and there's the Singaran switch that saw these flows. So I'll be working with, oh, sorry, my bad. We're on to the next one. But what this shows is in that stage, you can see what sensors are seeing your traffic. And that's how we're identifying traffic that maybe is erroneous. So in this example, we saw this Kisti traffic on our near router sensor, which means that it's passing through our US sensor and going back over to Korea. So, and it's not an insignificant amount of traffic. It's not a ton, but it's not an insignificant amount. And that was only over 7 days. Over the 30-day period, it was in the terabits. So something to look at in the future. Singapore to Australia, we saw traffic from Singaran to ARNet traversing the US. I tried to find specifically for APAN some APONet examples for these new cases, just because this is APAN and most of us in the room are participants in APONet, including my organization and Singaran and SciNet and all of these people. So I'll be working with Warwick Mitchell, who is a co-chair of our group, and Simon Peter Green to take a look at this traffic. Because Singaran to ARNet doesn't really make sense that traffic should not be seen in LA or in Seattle. It's not an efficient, it seems like not an efficient route. Sometimes as I say, sometimes we work on these cases and discover that's completely intentional. But I don't know if in this case it is. And then the last one I have that we've been working on for a few months that I need to get a little bit more traction from, but I'm working with engineers from WIDE on, is we saw several institutions in Japan to France, traversing the US via Transpac. The engineers from France confirmed that the opposite direction, so France to Japan is taking CAE1, which is seemingly the correct route, CAE connecting Asia and Europe. So we're looking at why traffic from WIDE specifically is going to France over Transpac. So we'll be working with WIDE engineers over the next month to hopefully fix that case.
Traffic is taking a different route from the other traffics, because usually the traffic
Correct.
actually comes down to us and go CAE1.
Correct.
Or they take the Trans-Siberian link and go across.
Yeah, so WIDE specific traffic is taking Transpac. But the other direction back, it's taking CAE1.
I think that the going from the Japan to France, in that sense, basically WIDE can't use the Trans-Siberian link from the SciNet. So in that sense, the Japan to France is the fast way. It's going through Transpac.
Okay.
So the other way around, it's actually slower than.
Okay, so this might be a good example of it
Yeah.
was intentional.
Yeah.
So this routing is asymmetric. It is going
Okay.
two different ways, but it may be intentional, is what you're saying. Okay.
What you're saying is that at the Tokyo Exchange is taking the link across the Trans-Siberian link.
So the going through the Trans-Siberian links is not for everyone in
Okay.
Japan. So
Okay.
especially the WIDE case, so the fastest way to go into the Europe is going through US. So because the Earth is round. So going to Singapore is far away.
Because I think we saw the latency, right?
From wide point of view, I'm from wide project, and it seems to be what the things what the problem is. So it's this kind of the asymmetrical routing is the problem, or is there any transmission problem within what's happened within the wide and the runner? So I mean if the correct way to go to Japan to France is the CAE1. I mean, it seems to be the route announcement from White project is correct, but the other opposite side for maybe route announcement from Runata is coming from the barrier US, I think. So it should be this kind of the routing must be same as the go and back. Maybe Renata routing policy or something, right? A configuration or something like that should be fixed to fit the back and forth, I think.
Yeah, so two things that I would say would gather from that. I would say the routing working group is not here to tell you how your traffic should go. We are just here to identify what's happening and determine if it's something that you want to look at. That is not, our job is not to tell you how to move traffic. So just that point. And then second, we as a routing working group should talk to Renater because they are saying the exact opposite of you. They're saying it's wide. So we're playing, you know, the Spider-Man meme. That's what's happening right now.
Yeah, and so of course there's someone complained about this routing folder. So
Yes.
from
Renater, yes.
From Renater, okay.
Yeah. So what we need to do is confirm from the wide end what you all are seeing, and then inform that group and have a discussion within the routing working group about, or via email or Slack or whatever mode of communication we want to use about whether CAE1 is the right way, whether the way it's going is what you expect, and that's fine. And if you want to fix it or not, you know, like I said, we're not in the business of telling you how to run your networks or what routes to take or what's most efficient. All we want to do is make sure that there's a community for you to come to and discuss these issues with. And so I can connect you. We should meet after this, and I'll take your card and I think you're in the routing working group, aren't you?
I'm in the working.
Yeah, so we can connect and we'll get the right people on the email and we can see what the next steps are.
Yeah, to solve that. Okay,
so
thank you very much.
What just happened there is a perfect example of what the routing working group is trying to do, is bring people together, find a potential problem or something to look at, bring people together, find those contacts, and then collect them so that they can make forward progress. And the last thing, I believe, well, close to the last thing that we do is tool talks. So we've had a number of tool talks at the routing working group. So we've had Manners, Router Proxy, Peering DB, Internet 2's Routing Integrity program from Steve Wallace has come to talk. We've had several PerfSonar workshops, specifically using PerfSonar to identify routing anomalies. And then the new PerfSonar 5, we just had a presentation on that. MicroDep, NetSage, which is the platform that I use to take a look at these routing issues. Professor An's group has come and talked to the routing working group before, and then Ripe Atlas has also come and done tool talks. We have all of these tool talks available to the public. So if you didn't get to go to the routing working group meeting, we have the slides and the video from the tool talks available at these links and on our website. So you can, if you missed the routing working group meeting or you're just interested in any of these topics, you can go and watch the slides or the video, read the slides or watch the videos, and get an opportunity to learn a little bit more. And the final thing, what have we learned in these 2 years, and where do we want to go? So I've mentioned this quite a few times in this presentation. It's created new connections and resources within the RNA community to reach out to and rely on. It appears, based on the attendance at the routing working group meetings, we usually have anywhere between 20 and 40 people at our routing working group monthly meetings. There is an eagerness within the community to work together and to take a look at these issues and to build that community. So that's one of the things we've learned. Via the tool talks, we've learned there's a wealth of tools and information out there that exists to help optimize routing for science and to help us do our jobs. And it's important, like I touched on earlier, to educate all of our engineers on some of these tools, because we don't always know that they exist, and we don't always know how the community is using them and what's the best way to use them. Solving these issues can be a great challenge. I think that's one of the things that I've gleaned from doing this group for 2 years. It's a very challenging endeavor. It's worth it, I think, but it's challenging because there's so many distinct networks, there's so many engineers in this community, and there's so many policies that are affecting the way the GREN is coming together as a system. And I think the final thing that I've learned in the last 2 years is that we need to continue this engagement, and we need to have more engagement from the community, because our networks are continually changing. All of us are JAONT is doing a huge refresh this year over the next 3 years. 400G is coming. There's all of these things coming that we want to make sure that the community is engaging each other on, and making sure that we have a place to collaborate and have the right contacts to be able to solve and troubleshoot issues that we see as a community. So our next meeting is at TechX in September. And then we have an October meeting, October 17th, 8 p.m. Eastern time. So that will be accommodating for our Asian and Australian folks a little bit better. We've had a lot of European facing meetings this year just based on when presenters can present. So our next meeting will be in the sort of Asian reaching time zone. No meetings in November, December. I am heavily involved in SC, and many of us sitting in this room are going to be heavily involved in SC. So we are going to be taking a break in November and December. So we will pick back up in January, and hopefully have some new cases or have all those cases solved and be on to new cases. So at this time, I would like to hand it over to Professor An, and she can give us an update on her project.
Hello, everyone. And just now, Bruna gave a great presentation. She talked about some challenges we faced. To solve all these challenges, we need data. We need to analyze the collecting data, and then we find where the problem is, or we prevent the issues before. So the project, APAN IC Fund project, developing a collaborative BGP routing, analyzing and diagnosing platform. The motivation of it is to provide more tools, can done some work automatically, and provide some tools to the operators. This is a work from many collaborators. We have team members from 19 organizations. I would like to read their name here. There are RNet from Australia, APAN from Japan, BitRing from Bangladesh, CERNET from China, DUSTSTI from Philippines, and RNet from Indo, and a university, Göttingen University from Germany, Hurricane from Hong Kong, and ITB from Indonesia, CareerNet from Korea, Learn from Sri Lanka, MyRain from Malaysia, and NRain from Nepal, Prawn from Pakistan, Rian from Netherlands, and Singarin from Singapore, a university from England, Surrey University, and Terran from Thailand, and Transpec from the United States. All our team members, we work together, and we work, do some work, and do some development, do some deployment. Here is the outline of my presentation. Firstly, I will introduce the background, and then the project progress, the achievement, and the future work plan. And we would like to, our listeners can give some comments and suggestions. This project have been going 18 months till now. It will be due by this August. And then we have applied the next phase, the extension phase of another 18 months. So all your suggestions we will consider in the next phase of the project. First, I will introduce the background. So to improving the internet security and face all the challenges to improve the availability and provide tools for operators. First, we need to do data collecting. There are many data such as registration data from who is RRR, peering DB, and RDB, ROI, all this data. And we have looking glass. We can do some trace routing, get routing information, and we have routing information from route views, RACE, all this, and also some active probing tools such as persona, such as Atlas, and some passive measurements as just mentioned the NetSage, all these tools. Here I will focus on the first three, data collecting. And after all this data collecting, we will do data mining to find what we need to find the problems. So we will do statistics, and we will do by machine learning and deep learning, all these tools. And after this, all the data will be applied to some objectives such as hijacking, leaking, outage detection, and interdomain topology discovery, monitoring, peering, and path changer, and performance monitoring, and link level congestion detection. And Bruno just mentioned the routing from other countries and cyber attack detection. There are many registration data. Some have been collected and be analyzed, and we can get many data from Peering DB and Hurricane and IR Explorer and RDB, many registration data. And there are looking glass vantage points. Some famous vantage points such as tracerouter.org and Peering DB and BGP4 and bpLookingGlass.com. And still there are many other looking glass pages that can be found and explored easily. We have done some work to find the obscured looking glass site. And also there are some routing collection vantage point, such as rapid race and route views and PCH. All this, they can provide some routing information. So, and also there are many application platforms. Some are open, such as Manners Observatory and IOTA and Cisco Beachstream. And also there are some commodity platforms such as Catchpoint, Southern Ice, and Kentic. I think all of our engineers know all these platforms well. So is it enough? We have so many resources, so many tools, so many platforms. Is it enough? What's the meaning of our project. We know that there are over 70,000 AS, and most links haven't been monitored, especially in our Azure area, and data isn't maintained effectively. Sometimes some data are confusing, and so we think that data is worth digging further into by combining big data from multiple perspectives. So the motivation of our project is that we hope to contribute to the community by communication, learning, studying. All our team members, we learning together, we improve ourselves, and so we can improve the efficiency of the networks, and we can learn from a different perspective, so we can do something from a different perspective. We want to do something that others haven't done. Next, I will present some work we have done. Firstly, we deployed a Looking Glass platform and a BGP routing sharing platform, a BGP hijacking detection system, and a BGP monitoring tools for operators. Here is a brief of our activities. To build a collaborative community to enhance the capacity of our NRIN's network operation and management, we setting up a project website. On the menu and the video we put in the website. All of our partners can contribute to the menu, to all the video, and they can share all the knowledge. And we establish a distributed BGP routing monitoring platform and a Looking Glass platform. And now we have 15 partners connected to this platform, and 7 partners connected to the Looking Glass platform. And also we add links to other partners which they have deployed Looking Glass platforms. And we provide some tools for operators, include the dashboard, a routing path search, and users can register and get some alarm emails. And we deploy a BGP hijacking detection and mitigation systems, and analyze the robustness of routing in the Asia Pacific area. And all this work is almost done. And also we share knowledge among our community, knowledge including RPKI, manners, and BGPsec, DNSSEC. We done all the work, we published some paper, and we are preparing the final technical document. We plan to finish all the work before this conference, but the workload is a little higher than we expected. So now it haven't finished all. We maybe finish all the work by a couple of weeks, and then we will write all the menus and prepare all the videos, and then it's a milestone of our project, the first phase of our project. This is our project website. You can access it. Here is the website, the domain name, the first page, the documentations, the meeting materials, all the presentations at different meetings and the technical document, we put it here. And all our partners' information, our news and event, all the information we put into the website. We have established BGP sessions with 15 partners, and all the documents, how to set up BGP sessions. you can find in the website. Here we have two collectors here. You can pair with any one of them. If you are interested, you can contact with us, and we would very happy to connect to set up pairing with you. This is the Looking Glass platform. Here is the website, and we use open source, and we limited the query speed for security. And we have 7 partners linked to this Looking Glass, and some we add the link to our partners. Just as I have just talked, that there are many obscure Looking Glass sites. So we do some research on this, and we published a paper on this for this work. And we find over 2,000 Looking Glass vantage point, and some haven't been covered, some haven't been covered country include, and haven't been covered cities. And all the work, here is the open source. You can find all the open source and the Looking Glass site here, this URL. And using all these obscure Looking Glass vantage point, we can improve the completeness of S-level topology. And we find some new S and some new links by using all these obscure vantage point. And here is some work we try to provide some tools for hijacking detection and statistics and dashboard for our partners. I will give a brief presentation for all this work. Here is the hijacking detection. The work is prefix hijacking. Is based on knowledge-based and mostly based on modes. That is, mode as the announced the same prefix, and then we filter all the information, rely on domain knowledge such as ROA, RR, and S relationships. Here is the website of the platform. This is the first page of the platform. We give some statistic information. You can put your the time period here, and it will give some statistic information and attacker, victim, and the history curves. Here is the page of the anomaly. You can filter by the event level and harm level, event time, harm level, and time period, and duration. Also, you can download it here. And you can search by S number, prefix, all this information. We evaluate all the hijacking and give them different levels. So operators, they know which is critic hijacking, such as here. And there are many websites. Maybe it will influence the operating of all these websites. The system will respond quickly, and we have an event replay function. Here you can click each time point. You can see the path change of each time point, and also we permit users comment about the hijacking events. Maybe it's a real hijacking. Maybe it's just a prefix sharing. So users operators can add comment here to the events. Then we can collect more information. Maybe we can training all the hijacking events by machine learning. And we do statistics for the anomaly events by country, region, and yearly, monthly, and weekly, and daily, all the information, all the statistics information. You can generate report based on the statistic information. The dashboard is for an operator. They can input the S number of them or the organization name. Then the information of the S number will be shown, or all the S number of its organization or the organization will be here, will be shown, and he can just then click one S number to get the detailed information. Here we can see the prefix change and the prefix distribution, and all the prefix here. For the operators, it can search the prefix and see that prefix change of the AS. And in the dashboard, we also give some key information, key pairs information, which pair is important to them. We can see the import and export as numbers to each pairs. And also we have a table to list all the neighbors of them, all the neighbor information. Also, routing is important. Routing part is important for operators. Mostly they want such a prefix and their routing. Here we get the routing table for all our team partners. When a user input a prefix, or it can be IPv4 or IPv6, or the subnet, you input a /32 prefix, but it will, am I okay still? It will list all the subnet of it. Sorry, some error with the connection. It will reconnect. Sorry for the interruption. Maybe we can, if you have some questions, we can discuss now. It's okay now? Okay, we can proceed. So we think this is helpful for operators. He can know each of the subnet. Maybe they will go different paths. We can see each group of prefix, they have different paths. Lately, I will give a demo of the system. And we generate a reverse routing path for a prefix. So it is helpful for operators to know which S is important, is key, and how about the architecture of the reverse path. And also we have another interface. It has good interaction, better interaction, and users can input, can click, can search. Also, we have bi-direction routing paths. User can input two prefix here, and it will show the path from left to right and from right to left. These two prefix is from Terrain and from Learn. We can see that the forward path and the backward path, they are different. So it's deep, this information is helpful for operators. Maybe we can do some analysis to all the routing paths and give some report. And also users can subscribe their AS. And then when there are some change with their AS, they can get alarm email when such as prefix change, some new prefix or some prefix missed from their AS. And he will get an email or can click get the detailed information. Also, he can monitor the peer changer, such as this as the changer, the peer. Each day, there are peer changer for it. Here, follow it at the table shows there are 2 peer disappeared from this peering. Maybe it can have a deeper look, the manager, the operator can have a deep look for this information. And we are interested to path change. You can monitor from S to a specified prefix, and then you can see each day, maybe the path will change. We haven't finished this work finally. We just list the path of each day. Maybe in the future, we can add some alarm information to point out the change of the path. Also, users can subscribe hijacking events for NIS, and then he can see the hijacking events for his IS, and also he can add comments here, and he can get email from the system for the alarming. Also, we give some top presentation of some country and region. Users can select the country region, and it will show, the system will show a high level architecture of the country's network and the top AS. And we have prepared the menu and the video. All the menu and the video are prepared by BitRain. And this menu and video are prepared in this May. And we will prepare a new one, maybe in September. And we have put all the menus, how to configure, how to configure the peering, how to configure looking glass, and some report. We put all this menu and video in our website. Among this period, over 18 months, we discussed with all our teams, and we get many useful, helpful feedbacks. Here, I would like to list them, and and thanks for all the comments and suggestions from all our team members. Some suggestions we have done, some bug we have fixed, and some we have fixed early, and some we have just fixed lately. Just as I presented, we have added the function that users can configure interested prefix and AS and get alarm information and anomaly information, and BGP related such as peer change and path change. We just added it. We have planned to send a message by Slack channel. We will do this in the next few months. And some partners are interested to show alternative routing paths and tracking multipaths, we will do this in the next phase because the work load is a little heavier. Many data have been collected and analyzed, and we are interested to the past performance, just as Bruna talked. Yes, we have found some looking glass vantage point. We will add all this and monitor more past performance. And some remedial measures to send alarm to the owners of the victim. We have added in the subscript function. And some partners said that there are missing paths. We tried, and we have used some clustering method to solve this problem, and all the API for receiving data to provide API to some other developers. We will consider this in the next phase of the project, and we are like to open source the project. But there are some difficult to maintain all the source code. If some partners they have some experience in this part aspect, we can discuss. Maybe you can give us some help to how to maintain a project as an open source. There are many data, huge amount of data. So we are trying to do parallel computing and clusters to handle all the big routing data. And this is the architecture. We have improved this by this clustering and parallel computing architecture. We get all the routing information and we process that data, and we use Kafka and distribute that to the many consumers. And finally, we get all the result data and combining them together, we get the final result. This is the work of now of this phase of the project. For the future work, we have submitted a new proposal, an extension of the ongoing project. It will continue for the next 18 months. This is a draft objectives of the project. We have found some looking glass vantage point. We will develop an integrated looking glass platform and provide API. So we can leverage all this looking glass written data to users. And we would use all the looking glass to further check the hijacking at the data plane to improve the detection accuracy. And now we just do the prefix source hijacking detection. We will do path hijacking detection and routing leaking and outage all the detection. We will consider all this work in the next phase of project, and we will continue to maintain and fix all the bugs and continue the community development and collaboration. Here I will give some for the future work. We have done I have made some preparation, such as we have found many looking glass sites, and we are developing a integrated looking glass and OpenAI. This is the testing platform. It haven't been put into production. Users can select any vantage point, and it can then and do and then it can select the action, and then the platform will done the looking glass action for them, or they can use the API. And for the path hijacking detection, we have done some research, and we have published a paper at ISCC 2023. We all know that S-link hijacking is difficult to detect, because it can evade the most detection. So we are considering now most of state-of-the-art the technicals. They think they treat all unseen links as malicious links, but this isn't true. So we try to predict the links and the unseen links, and predict which is benign and filter them. So is this S-link predictable? Yes, we have searched this, investigated, and they have some graph characteristics of S-level topology, some power law distribution, negative degree correlation, all these hierarchical, all these attributions have it can be predictable. So we put all this information into we training a machine learning, and then we use it to filter the new found links. So we get all the data and we filter it. We filter all the new as emerged, or it's a new link from known as. With different unseen links, we use different message. Firstly, we get the reliable links, and then we use a link predictor. We training it, and we generate some negative samples and some positive samples, and then we training it, and we also use some rules to help filter the hijacking, to filter the events. And as our evaluation showed that all the negative samples, they have a lower value, prediction value. So we use this information to predict the link, and all the positive aspects, they have a higher value, and the hijacking, we can detect the detection rate of the path hijacking is over 80%. And also we give some examples here. I want to show the detail. If you are interested to this, we can discuss later. This is the evaluation, and this is it for my presentation. And I would be happy hear suggestions and comments from you. Thanks, and contact us at this email. If maybe you can some comments I would like, and now I would like give some demo. If you are interested, you can see the demo. Yeah. Yeah. Yeah, I will show some demo. Web PHP watch. The network is a little laggy.
Does anyone have any questions or comments for either presentation while they're setting up the Zoom? Yes.
This is the first page. This is the website of the system. And first, we can show the victim and attacker here and some static information. And we can see the anomaly, all the event time, different event time, and different levels, high level, at level. We can see time period. We can show the detailed information of this events. We can see all the website. We can click the website and see what about the website. And we can see the event, how the event going at a different time point. And also we can comment here, edit comment here. And dashboard, at this dashboard, we can see the network, the prefix. And here are some peers. All the peers information. And here is the key peers, IPv4 peers and IPv6 peers. There are a few. And routing paths, I think I would like to show the routing paths. We can see that the routing paths, they have, for this /16, there are routing paths for many subnet of it, /22 and even, but they have different routing paths. And we can input another prefix here. Yeah, we search it. We can see that, yeah, the routing path is different routing paths. So if an operator want to look the routing paths, maybe it have to search in the routing, use many commands. But in this system, it's easy to show that the path for different prefix. We can see that from HARNet, from different and HARNet, the routing path is different. Yes, and we have the reverse routing path for it. We can see that topology routing path for it. Yes, many nodes. So we can hide maybe the layer. There are many layers. We want to see some higher layer for it. We can click here. We hide some layer from it. Oh, still many. Maybe we only show 2 layers of it. It's little. Yeah. And if we want to know the path of the routing path of it, we can click we can click any node, and we can see that the routing path is highlighted. Also, we can search, we can input an S number here, and the routing path will be shown here. Also, we have the bilateral meeting paths.
2 minutes.
Yeah.
2 minutes.
Okay. And we have documents, video. You can see the video and look at the PDF. I think it's okay. So do you have any questions? So please contact us if you have any comments later. Thanks for your joining us. Thanks.